Recording in progress.
Good morning, everyone. Participant of summer course, forestry summer course. Today we start another theme of our summer course, and we continue with other theme regarding. Let me see the title. Importance of ecosystem services in mangrove forests. And our speaker today is Mr. Yosuo Limura. He's a Doctor Agriculture of Soil Science from Kobe University. And he got Doctor Agriculture on Soil Science in Kobe University in 2011. And now his affiliation is in Department of Biological Resource Management, School of Environmental Science, the University of Shiga. And he is a lecturer and researcher in the institution, and his field of study is soil science and ecosystem ecology. Now the time I will give the time to Mr. Yosuo, and perhaps we can get anything important regarding the ecosystem services provided by mangrove forests. Mr. Yosuo, the room is yours.
Okay, thank you very much for introduction at me. So, good morning, everyone. Can you hear my voice? Okay. So let's start. My name is Yosuo Limura from the University of Shiga Prefecture, Japan. And thank you for inviting me to the first Mulawarman summer course program today. Before my talk, please watch the video message from our department chair, Professor Ilie. I will share the video message. Wait a minute. Can you share the video? Okay.
We see.
So let's start video message.
No sound. Mr. Yosuo. So Yosuo, we can't hear anything.
You can't hear?
No sound.
No sound?
Yes.
Oh, wait. You cannot hear? You can catch a sound? No.
Yeah. Still no sound.
No sound. Okay. So now I will talk. I will start my talk. Okay.
Okay. Yes.
Okay. Yes. Okay. Sorry. So it's a problem for sound. The video message. Okay. So now I will share my slide. can share the slide, okay?
We can see.
Okay, yes. Okay, so I will start my talk. Today we talk about the importance of ecosystem services in mangrove forest.
Sudah mulai dia. Itunya Mbak di mana ya?
With a special focus on bare ground soil and the dissolved organic matter produced from soil and plant litter. At first, let me introduce myself. My name is Yosuo Limura. Nice to meet you again. And I am a lecturer in the University of Shiga in Japan. I belong to the Department of Biological Resources Management, School of Environmental Science. My specialties are soil science, particularly in soil organic matter dynamics, and also ecosystem ecology, particularly in carbon cycle interest ecosystems, including soil organic matter carbon cycle dynamics. And my hobby and my favorite is playing with my two kids. I have two sons. So this is today's content. I am sure you are all well known about this, but first, what is a mangrove? I will briefly talk about this. And second, I will talk about what is the ecosystem services and then this in the mangrove forest. And third and fourth, I will talk about the carbon accumulation process and the soil and the supply of trace metal elements to and nutrients to coastal waters via dissolved organic matter, which are considered to be particularly important among the ecosystem services in mangrove forest. So let's start with what is a mangrove? Mangroves are the only saltwater woody plants on Earth that inhabit brackish waters in the tropics and subtropics areas. Their morphology, which differs significantly from that of cormorant trees, especially their root development adaptation to anaerobic soil and water and salt tolerance, have long been of interest to ecologists. We can see very unique root form and above ground like waters, this water, like this. They fix oxygen from the air effectively through these unique root systems. Since the 1980s, the biogeochemical and ecological functions of mangrove forests have been studied. According to one theory, the word mangrove is a compound of Malay word mangi-magi, actually you know, and grove in English. About 70 to 100 plant species are known to comprise mangrove worldwide. This map is the location of mangroves over the world. Indonesia in here, you have a very big area in mangroves. And Japan is only small areas, only here. Now we'll talk about the geographical conditions for mangroves. Roughly, there are two types of locations where mangroves are established. One is an estuary type, like this photo. This type exists in river estuaries and is formed on tidal flats formed by sedimentation by rivers. The other is an oceanic type. This type is found on tidal flats in lagoons and marshes in quiet environments created by sandbars and beach breezes formed on the seaward side of the sea. As I mentioned earlier, there are about 70 to 100 mangrove component species in the world. At the family level, there are 3 representative mangrove species. The first is Rhizophoraceae, of which Bulgaria, the spores, and Rhizophora are well known. The other is the Biogeochemical, which includes the Sonerati as Abyssinia is known, this photo. And the other is Soneratiaceae, which includes the Soneratia, like this photo. This can be found in Japan and Southeast Asia too. Okay, so next, let's look at ecosystem services in mangrove forests. Have you ever heard of ecosystem services? Ecosystem services are functions that benefit humankind and are based on the concept of biodiversity, that ecosystems supported by a diversity of organisms provide tremendous benefits to us. This concept is divided into several types of services. One is a provisioning services, which provide the base for our living. They are services that provide resources important for human life, such as food, fuel, timber, fiber, medicine, and water, etc. And next, there are regulating services. These are those that provide secure living. They are services that control the environment. For example, forests moderate the climate, make breathing rest, and purify water. Next is the cultural services. These are those that provide a rich culture. These are services that provide spiritual fulfillment, aesthetic enjoyment, a foundation of religious and social institutions, and also recreational opportunities. The supporting services are those that provide the foundation of the provision of these 3 services. These provide the basis for the survival of life and are important services that support the provision of the 3 services above, such as oxygen production through photosynthesis by plants, soil formation, nutrient cycling, and water saving. Thus, the environment provides us with many benefits based on biodiversity. So let us now look at what ecosystem services are provided in mangrove forests. First is focused on provision services. Mangrove forests are established in brackish water and have a good water environment for organisms. Therefore, they provide good fishing grounds. The trees themselves also provide fuel, such as charcoal. Many Indonesian mangrove charcoal are imported to Japan too. And mangrove forests are also important as a home for many organisms and create great biodiversity. This is an example of regulating substances in mangrove forest. First is a substance that reduces damage from typhoons and waves like a tsunami. It is said that mangrove logging was one factor in the 2004 tsunami in Indonesia. And the second is water purification. The complex root structure of mangrove forest helps to remove suspended substances from the water. Next is carbon accumulation. I will discuss this in more detail later. So mangrove forests are known to have a very high function of accumulating carbon as an ecosystem. So next is cultural services in mangroves. In mangrove forests, ecotourism is one of the cultural services. For example, kayak tours are offered in mangrove forests around the world to enjoy nature, including kayaking through waterways to observe mangrove forests and the various organisms inside the mangroves. And finally, there is a supporting services in mangroves. In mangrove forests, the growth of mangroves facilitate the accumulation of sediment from upstream, leading to soil sedimentation. Soil formation in mangrove forest is related to the supply of various materials to coastal waters and is also closely related to the carbon accumulation I mentioned earlier. Thus, mangrove forests provide us with diverse ecosystem services. Today, I would like to focus on one of them, the supply of materials to coastal waters through soil formation and dissolved organic matter, which is a supporting services. I will also look at carbon accumulation in mangrove forests, as this is closely related to the regulating services. So I will now talk about soil formation and carbon accumulation, which I consider particularly important for mangrove ecosystem services. So now, let's see how much carbon is stored in mangroves. This is an example of our research group investigated in the mangrove of Ishigaki Island, Okinawa, Japan. Ishigaki Island is located in the southwestern part of Japan, and here belong to the subtropical zones. The study site is a mature forest dominated by mangroves of the large forest area. The amount of carbon storage and the above ground trees was 80.7 megagram carbon per hectare. And the amount of carbon in the soil up to 90 centimeter below ground level was measured to be 251.0 milligram carbon per hectare, and total is 331.7 milligram carbon per hectare. It was calculated 3 times more carbon was accumulated in the soil than in above ground biomass. In some places, the soil was deeper than 90 centimeters, so it is likely that much more carbon is potentially stored in the soil in this area. So this slide later is another example of a study conducted by our group. This study site is in the Trout River estuary in Thailand, tropical area, and rice forest area is dominated in this study, in this site. This mangrove has very deep soil deposition, averaging more than 3.5 meters. We measured the amount of carbon stored in the above ground biomass and in the soil up to 3.5 meters. The results showed that 99.7 milligram carbon per hectare was stored in the above ground biomass and 961.7 milligram carbon per hectare in the below ground soil. The total is 1,061.54 milligram carbon per hectare. Above ground biomass was similar to that Ishigaki Island mangroves, but the amount of carbon stored in the soil in Trout River estuary was about 4 times greater than Ishigaki Island in Japan. This is largely due to the depth of the soil. We can find a very clear relationship between the soil organic carbon stocks and the soil depth. In addition, the soil stored about 10 times more carbon than the above ground biomass in this area. So considering with Ishigaki's data, it is clear that soil is a major part of carbon pool in mangrove forest. So this is the result of a meta-analysis of the amount of carbon stored in 1 meter of soil in mangrove forest. On a global scale, it seems that soil carbon content of mangrove forest tend to be higher at higher altitude, and lower altitude, when compared at the same soil depths. It also showed that soil carbon content tend to be higher when the above ground biomass species are more diverse than when they are simple. So this is another meta-analysis of forest ecosystem carbon pools in various climate zones and in the tropics. These results show that mangroves are most carbon rich in the tropics and have extremely high carbon stocks compared to other climate zones. Oh, sorry, the charm is static. Okay, so this is the mangrove forest, and this is one subtropical tidal marsh, and this is the tropical seagrass bed. This is the tropical humid evergreen forest. This is a tropical peat swamp forest. Mangrove is the best and the most carbon-rich forests in the tropics. On the other hand, is the mangroves data is here. This is the boreal and a temperate and tropical upland. So mangrove is the most carbon-rich among the climate zone and several climate zones. Thus, mangrove forests are the most carbon-rich forest ecosystems. In addition, much of the carbon stored in mangrove forest is put in the soil. This is data, which in many places account for more than 90% of the total. In other words, soil plays an important role in carbon accumulation in mangrove forests. So how can mangrove forests accumulate so much carbon? Carbon accumulation capacity in forest ecosystem is generally evaluated in terms of net ecosystem production, for short NEP, which is the difference between primary production by plant biomass, for short NPP, and respiration by heterotrophic microorganisms, for short RH. This is formula, NEP equal NPP minus RH. It is well known that mangrove forests have very high NEP as a result of abundant primary production and low heterotrophic respiration based on anaerobic conditions under the water, which has been attributed to high carbon stocks, especially in the soil. Similar results have been shown by tower flux observations, a macrometeorological approach, and biometric observation, non-ecological approach. But it has become clear in recent years that those observations have significant shortcomings. I talk next. Unlike most terrestrial ecosystems, forest ecosystems, mangrove forests are affected by tidal water dynamics, which affect the dynamics of materials. For example, Wita, such as fallen leaves, is usually deposited directly on the soil surface, but in mangrove forest, litter supplied to the soil is discharged to the coastal waters due to tidal effects. The extent of this discharge varies depending on the topography and the species of the mangrove forest, but on average, about half of the litter is discharged worldwide. As a result, it is estimated the mangrove litter account for as much as 11% of the global transport of organic carbon from the land to the ocean. It has been shown that not only litter, but also particle organic carbon, for short POC, and dissolved organic carbon, for short DOC, and dissolved inorganic carbon, for short DIC, are also discharged from mangrove forest soil into coastal waters due to these tidal effects. So we need to understand how much materials like litter, POC, DOC, and DIC from mangrove forest into coastal waters, and considering it to a calculation of NEP. So our research team conducted a study in the mangrove forest on Ishigaki Island and found that the same amount of carbon as net ecosystem production is mainly discharged from the estuary to the sea as dissolved inorganic carbon, Similar research have been reported in several recent years, indicating that NEP values for mangrove forests based on previous methods may be an overestimation. However, the fact that there is a large pool of carbon in the mangrove soil suggests that there is a process of carbon accumulation that we have not yet determined. In other words, missing carbon. Thus, the process of carbon accumulation in mangrove forests that we have not yet captured are root production, including root turnover, and the process of carbon accumulation from dead roots to the soil. Our study team believed that quantifying this process, we have to clear the missing carbon in mangrove ecosystems, and we can calculate a certain NEP in mangrove forest in the future. So next, I will talk about the importance of dissolved organic matter, for short, DOM, mangrove forest. DOM is a generic term for natural organic matter that is universally present in all aquatic environments. When DOM concentrations are high, its presence is easily recognized as brown-colored water, but it is also present in low concentration in clear water. DOM in mangrove forest is primary organic matter dissolved from litter and soil. It has been reported that DOM accounts for much of the organic matter discharged from mangroves to coastal waters, and in some locations may account for more than 90% of the organic matter in runoff. According to a well-known study that estimated the global quantitative contribution of mangrove-derived DOM entering the ocean, 10% of DOM entering the ocean from the land is persistent DOM from mangrove forests. DOM is classified into humic substances, for short HS. It's a hydrophobic fraction, and non-humic substances, for short LHS. It's a hydrophilic fraction based on their relative solubility in water. Humic substances have a darker color than non-humic substances, like this follows. The humic substances in DOM has extremely complex chemical structures characteristics, making it difficult to decompose and highly curating, and it also functions as a driver for various trace metals and coastal waters to coastal waters. For example, iron precipitates in seawater in the seawater environment and becomes unavailable to primary producers. But by forming a complex with humic substances, iron is persistent. Iron is present in seawater in a dissolved form and becomes available to primary producers. Non-humic substances contain biogenic proteins, lipids, amino acids, and sugars. And It's biodegradable and a source of carbon, nitrogen, and phosphorus for heterotrophic microorganisms. Thus, DOM is a key substance that supplies various materials from mangrove forest to the ocean and plays an extremely important role. The carbon storage function of mangrove forest is another important substance, but even if the current annual CO2 fixation of mangrove forests distributed in a limited area, the impact would be small because it is only a 0.55% of the global annual CO2 emission. For this reason, I think material supply to coastal waters via DOM to be the most important ecosystem services in mangrove forests. As you are probably aware, mangrove forests are unfortunately on the decline, mainly due to land use change by humans. Global average area of mangrove forest is decreasing by 0.16 to 0.39% annually, and in Southeast Asia, which accounts for half of the mangrove forest area, the decrease rate is estimated to be as high as 0.30 to 0.67% per year. Thus, it is necessary to understand the causes of the loss of mangroves and establish appropriate conservation methods for each region. Our study team continues to study various environments of mangrove around the world. For example, Shiga Island of Japan is a natural forest, and the Bank of Thailand is a afforestation area. And also in Thailand, the river is a natural forest. So I hope that young people will consider how to conserve the coexist with mangrove forest in the future. So this is today's top summary. At first, mangrove forests are important sites that provide a variety of ecosystem services. And mangroves among the most carbon-rich forests in the tropics, not only the tropics, but also among the several climate zones. And the soil plays an important role in carbon accumulation in mangrove forests. So this is accumulation services in mangrove forest is a very important ecosystem service, but I think this service is not so big impact for the global scale because the very limited area in mangrove, only a coastal line. So this impact is very, very, very small. And fourth, one of the most important ecosystem services in mangrove forest is the supply of trace minerals and nutrients to coastal waters via the DOM. I think this service in the mangrove forest is a very, very important and very big impact for the global scale. The last, important to establish appropriate mangrove conservation strategies for each region. So I hope that young people will take more interest in mangrove forests and think about conservation and coexistence in the future. So my talk is finished. That's all. Thank you very much for attention. Thank you. Thank you very much.
Thank you very much for Mr. Yosuo. So Mr. Yosuo start with the basic definition, I believe, what mangroves are. I think we already know and Mr. Yosuo also linked to ecosystem services, especially provided by mangrove, and he underlined two important ecosystem services provided by mangrove. First, in accumulating carbon, and turns out that much carbon is greatly accumulated in the soil. And also talking about DOM, ini bukan daerah operasi militer ya, dissolve organic matter, and then how the mangrove functional in these certain attributes. And maybe the process is quite confusing, I believe, but DOM is also related to carbon accumulation. And participants, I invite you to ask a question. If you have any questions, responses, arguments, please. And it's okay if in Indonesia. So. No question? So, Mr. Yosuo,
yeah,
the first part, the last part, you talking about dissolved organic matter, and then and how the mangrove have functional in DOM itself, and how the process of mangrove have a function in DOM. So maybe we only see the result, but the process involving in the DOM.
How to produce the
How
to produce the DOM from the mangrove forest. Okay. DOM usually DOM produced from the soil organic matter and a part of the Wita in the mangrove forest, like fallen leaves and dead roots, like this. So where there is a huge amount of organic matter, soil organic matter, this means mineral organic mineral complex at the soil particles and litters, dead roots, dead organic detritus is very big, produce and very have a very big potential for produce the DOM. I think in the tropics, like Indonesia, mangroves, it's very have a very big potential for produce the DOM in the mangroves and related to the coastal borders, I think.
Yeah, you also mentioned that some issue still lie in the mangrove.
Calculating the carbon accumulation.
Yeah, you say that the production of that root is still not known.
Yeah.
What do I,
it's a missing carbon, in the mangrove.
What if I say if the proportion is not too big, so we don't have to care about it? So I don't know. Maybe you have any you have any reason you say that maybe the depth is also a part of carbon accumulation.
Yeah, it's a very big issue for the calculation root production, as also root turnover. It's a very big issue because a very difficult methodology for accumulating these things. So it's a very missing carbon in the mangrove forest. So we have to calculate this part in the loan. So if we can detect it, I think we can calculate a certain net ecosystem production in the mangrove forest.
I'm not too. I mean, if we compare to the terrestrial ecosystem, and I don't know if they also consider the root as a part of carbon accumulation, and how how proportionate it's to carbon accumulation for whole for one tree. So maybe if we have any suggestion, maybe we can compare to what happened, what may happen in the mangrove forest. So I say in the first statement that why we think about the roots, maybe the proportion is not too huge, and we can ignore it. But Mr. Yosuo have any have a different idea? So maybe the methodology is not too perfect to dig more deeper, dig deeper on this issue.
Yeah. So now we can try this detecting.
So any response, arguments? So maybe another perspective from a terrestrial ecosystem. So, Bapak Ibu sekalian, mungkin ada.
Can I question one thing? Question? Okay.
To who?
Mangroves in Indonesia is also declining now.
Yes, I would say yes. Yeah, I would say yes. So, but the proportion is I don't quite follow the information about how decrease the mangrove in Indonesia. So, but we
the reason the
land
use changed by human.
Yes.
Okay. Not natural. Okay.
Not natural. Okay. Mostly is anthropogenic. So we have someone raising hand. We have Hesti Tata here. Can you switch on your video?
Baik, terima kasih Pak. Selamat pagi, good morning.
Good morning.
Yeah, thank you for your talk, your lecture on this of organic carbon in mangrove and the ecosystem services. Actually, I get used to work in peatland area, but now I'm interested in mangrove ecosystem as well, because it can be allocated in the same landscape. Mangrove and peatland are never in the same landscape. So many of I don't really understand about mangrove ecosystem. So now we are also listen about blue carbon. Could you explain or elaborate more about blue carbon, whether dissolved organic carbon also is measured as a fraction of carbon in mangrove, in blue carbon, or more explanation on the blue carbon, please. Thank you.
Okay, so blue carbon. You want to know more about blue carbon?
Yes, please.
Okay, mangrove is a part of blue carbon. The blue carbon means organic materials and the coastlines, including seawater or sea grasses, and it's all of the water products, seawater products. So mangrove area is a part of blue carbon. You know?
Yeah.
That's okay?
Yeah.
It makes sense? Okay.
Yeah.
Okay.
Thank you.
Thank you for question. Good question. Yeah.
Oh yeah. Another question, please.
Yeah. Please. Go ahead.
Yeah. Technically, I also wanted to measure dissolved organic carbon from our plot in peatland. Could you explain the methodology on the how to measure the dissolved organic carbon in the peatland or peatland in mangrove, please?
In mangrove. We try. We measured with take a core, peat core. 3.5 meters core. We use take one core. So and divided each 5 centimeter maybe. So take samples and analyze the carbon and the nitrogen. And the analyzing machine. Yeah, CN analyzer.
Oh, CN analyzer.
Yeah.
Oh, okay.
And so, also we measure the bulk density, so on. So
yeah, sure.
we calculate the carbon in the area.
So we bring the soil sample to the lab.
Yeah, sample, soil sample, core sample.
Can we
like auger?
Yeah. Can we measure it in situ in the area of? Can soil respiration or root respiration, we bring tools to the field for the dissolved organic carbon. Can we also measure the dissolved organic carbon in the field?
Yeah.
Oh,
in the field. Yeah.
What apparatus you use? What the apparatus? What the tools that we can use for measuring dissolved organic carbon?
But I don't answer what.
The apparatus, the tools, the machine,
Yeah.
What the name of the machine that we can use for
soil peat auger.
Soil
peat. The name of peat auger.
Yeah, the Ekman one. Yeah. I know how to collect the sample, but how to measure it using what machine?
So its point is very light, not heavy, because we we had to bring to mangrove mud, so easy to take, and we easy to walk in the around the mangrove swamp.
Okay.
But it's a right product is very important point to select the auger.
Yeah.
Yeah.
If
In
you
the case we make ourselves in the auger. Yeah.
Okay. And if you have any publication about this methodology, could you share with us so we can read and follow the protocols?
We have some papers.
Yes.
And how to sampling the mangrove cores.
Okay. Yes.
So yeah, one day, please send me email.
Okay. Yeah.
So I will send some papers to how to sampling the core in the mangrove forest. Thank you very much for your question.
Terima kasih Ibu Tata tadi ya.
Ya. Terima kasih Pak.
Saya panggil apa ini Bu Hesti atau?
Hesti ya, Hesti saja.
Bu dari mana Bu?
Saya peneliti di BRIN Pak.
Oke.
Ya tadinya dari XLHK.
Karbon Bu ya?
Iya karbon. Tapi biasanya saya bekerja di rawa gambut.
You interested in blue carbon?
Ya.
It's a very trend in the worldwide. Yeah. It's okay. Thank you very much for your question.
Yeah. So, Mr. Yosuo, we have a question in the chat. Yeah. I read it. So, my name is Oki.
Okay, nice to meet you. Thank you very much for.
I'm not Oki.
Cooperation.
And then, and I have new information about mangrove, especially about the soils. Yeah. And I have a question: what makes soil in mangrove have a big role in carbon sequestration compared to forest land? Yeah. So sorry. Jadi, the question is, what makes soil in mangroves have a big role in carbon sequestration? So compared to forest land, yeah? So mangrove is we see that the biggest proportion of a carbon turns out in the mangrove soils. From your explanations, please, Mr. Yosuo, you can respond it.
Oh yeah. Can you hear my voice? Okay.
Okay. Yeah.
Okay. The why the carbon in the mangrove forest is bigger. I think it's important thing is the depth of the soil in the mangrove forest. It's a very deeper in the soil in the mangrove forest compared to the general terrestrial ecosystem, terrestrial forests. More than 4 meters, 5 meters, we can find the soil depth in the mangrove forest, but general terrestrial forest ecosystem is not find over the 1 meter. It's a rare. For the 2 meters, it's a rare. So mangrove forest soil depth is a very important reason for the big carbon accumulation in the mangrove forest. I think you make sense. Okay.
So related to that, so is it not confusing if we just say that the mangrove soil has the biggest proportion in the carbon accumulation, because so that means that the mangrove itself is not.
I think that mangrove forests have a very unique root systems and into the deeper soil. Also, root production is root can produce the dead root in the deeper soil. It's a very difficult to general terrestrial ecosystem, forest ecosystems. So it's a big reason for the carbon accumulation in the mangrove forest is higher than terrestrial ecosystems, I think. Yeah. So we try to detect this process. Yeah. Now I'm trying.
Yeah. Oki, Mbak Oki kan? Oh, halo ya. Mas Oki, gimana ya? Ada respon? Paham ya? Sudah dijawab. Thanks for the answer. Any questions, response? So maybe arguments so that we can confronting with what Mr. Yosuo was finding. No? So it's already 2 minutes past 11. Okay, I think everybody is satisfied with what Mr. Yosuo presenting today. And before we leave the room, we have a gifts. We have a gifts, certificate of about your participation in this summer course. Here we go, Mr. Yosuo.
Thank you very much. Thank you very much.
So thank you very much for Mr. Yosuo Imura, who participate as a speaker in our first summer course. Yeah, so this is we underline this statement. This is the first summer course that we start in Forestry Faculty of Mulawarman University, and then we honor that Mr. Yosuo Imura as a speaker in this summer course. Thank you very much for your material and your speaks today. Perhaps we can meet in another moments, another session of another seminar or else.
Thank you very much.
Once again, thank you very much, Mr. Yosuo.
Thank you very much. I hope the next opportunities to Thank you very much.
Demikian Bapak Ibu sekalian, jadi kita sama-sama akhiri sesi hari ini yang dibawakan oleh Mr. Yosuo Imura. Terima kasih atas perhatiannya. Thank you for your all attention. We see tomorrow with another team. Saya tutup dengan wassalamualaikum warahmatullahi wabarakatuh. Good morning and have a good health.
Waalaikumsalam. Thank you for Dr. Yosuo.
Thank you very much for
Recording
Thank you very much.
Bye.
Bye. Thank you.